All right, let's go. Okay. So, under the hood here with Mac OS, we're dealing with the Unix kernel, BSD Unix. Because what happened here is, Apple, Next Computers said, hey, we need a better operating system. So we're going to go and take a Unix operating system, BSD, and we're going to put a nice looking front end on it so it doesn't look like crappy Unix or crappy Linux, and we're going to call it Mac OS. They called their original front end, they called it Aqua. That was the name of their thing where you click these things and then you turn all those things off because your processor can't keep up with it and all that stuff.
So before Unix, what they were based on?
Before
Unix, before like OS X.
Oh, like what was their base operating system? Yeah. Before any of the Mac OSs came out, they would have been based on top of DOS. Mac OS was their graphical user interface operating system. And there was a company, have you heard of a company called Xerox? Probably have heard of Xerox. Copy machine people, right? Xerox had back in the early days of computers, they had a project called the Xerox Star. And the Xerox Star was their own operating system that was meant to be a graphic user interface based operating system with a mouse. They kind of created the mouse. And they decided, you know what, we're not going to get into the personal computer world. Instead, we're going to focus on copy machines. That's where the real money is, right? So they invited their buddies Apple in and just gave them everything. So they rebranded it Mac OS and started shipping it. And there was an interesting thing back then. Steve Jobs and Bill Gates were friends because early Apple computers. So inside of Apple, you had two different divisions. You had the Apple people and you had the Mac people. So the Mac project was a future-thinking graphical user interface thing built on top of that Xerox Star project. Apple was their flagship in education, running on top of DOS. It's running on Microsoft's OS. So they were partners with each other. So what's interesting here, and this is just how big companies work, I guess, it's always funny. You have Apple. It's probably not fair to say that Apple stole the OS from Xerox. Xerox invited them in and said, here. So, who knows what really happened, but whatever. But Apple is shipping their machines. So their first Mac was called the Lisa. Have you heard of that? The Macintosh Lisa. A lot of controversy over that because people are wondering why they name it Lisa. It was Steve Jobs he didn't claim her for a long time. It was his first daughter from somebody he wasn't married to. Her name was Lisa. So even after the Lisa came out, he still said, that's not my kid, and now we have DNA tests, and it was. So later in life, he did admit it. But in any case, that was running this graphical user interface. And Steve Jobs was on stage announcing this. It was his big presence that he has there on stage doing his keynotes. And about halfway through, he gets notified by somebody on his team that machines were shipping in China from Microsoft with a graphic user interface on them. And somewhere there's a video out there somewhere, I think, where you can see him visibly, his emotions change, finding that Microsoft had effectively stabbed him in the back. Stolen what they might have stolen. Who knows? So that's when they became mortal enemies. When they started shipping Mac OS, so now they no longer need the DOS people, right? And Microsoft starts shipping Windows, which looked a lot like Mac OS. Get it? So then they were enemies for a while, blah, blah, blah. And then they were friends, and the rest is history. But when we get into our programming language stuff here in a few minutes, we'll find out another enemy Microsoft made when we talk about Java. But anyways, Linux is another operating system, completely open source. The actual operating system is called the Linux kernel. So the point of this whole thing is that the kernel is typically what we call an operating system, and then the distributions are called Windows 95, Windows 98, Mac OS X, Raspbian Linux, Debian Linux, Slackware, Fedora, Red Hat, Ubuntu Linux. These are distributions of the Linux operating system. Does that make sense? The operating system itself is Linux, the Linux kernel, which is an open source project. Okay, so with that in mind, so here's some examples of Linux distributions. The version of Linux that I'm going to recommend that you use in here, although you can use whatever you want, is Raspbian, mostly because I'm gonna encourage you to run this in a virtual machine. You don't have to if you don't want to. If you have a Raspberry Pi, you can run it on the Raspberry Pi, which is a little small computer that you can download, hook it up to a monitor and keyboard, or you can plug it into your machine and use that as your hardware to drive it. But it is a fairly lightweight version of Linux, so it doesn't take up a lot of system resources, because if we are running a virtual machine, so what is a virtual machine? What does that mean to you?
It's kind of a software application layer runs on top of the kernel that
Okay.
may virtualize the distribution.
So a computer built out of software, right? That's what a virtual machine is. Instead of a physical machine with RAM and hard drives and things like that, a virtual machine would be one of those made in software, right? But what does it need to do? It needs to run on top of something. So this guy will run on top of a host operating system. So if I draw a picture of this guy, so on my computer here, we'll just use mine as an example, I have Mac OS running as my host operating system. Okay, that could be Windows, that could be Linux, whatever she's running Windows, you're running Mac, so on and so forth. It's interesting how many Macs we have in the room. But yours is Mac, right? So everybody in here is Mac except you. That is really strange. It's almost always the other way, right?
Yeah.
That's shocking. Huh. Interesting. Here, I can run Linux or Windows with you.
Are you running all of this at the same time?
Oh yeah.
Wow.
I have 64 gigs of RAM. that's the mic drop. So, but we're about to talk about how I do that here. All right, so you mentioned something about a layer, right? So I have an application running on here. The one I use, which is popular on Mac, is called Parallels, but there's competitors with it. So I'm running a software that's called a Hypervisor, which is a really cool name, right? It's just a fun name to say. So there's my Hypervisor. There's a couple different levels of Hypervisor in terms of how much does it let you get to the underlying hardware. We're not going to worry too much about that. Let's just assume this is a user level application that runs on top of my operating system that allows me to share some of my resources inside my computer. That's what it does. So examples of hypervisors are Parallels. VMware is a pretty popular one. VMware makes products for Windows as well as Mac. The Mac version of it's called VMware Fusion. Parallels is a Mac-only product. The reason I like Parallels is Mac has an API these days called Metal, which allows software developers to write stuff directly for the hardware. So in terms of performance of virtual machines, Parallels outperforms the other ones by quite a bit because I'm running it directly on my hardware. But you have to have a Mac to use Parallels. And any way you cut it, you can't virtualize Mac. So if you were going to be the jack of all trades, so now we're back to why do I have a Mac? If I want to be able to run every single operating system, I have to run Mac natively, and then I can virtualize all the other ones. Right? I can't get her machine and run Mac on it legally or conveniently. There are ways. There are projects out there, but ultimately you're not going to be overly happy with them. So if you want to run the Mac OS, run it on native expensive hardware and then virtualize everything else. But for you, what I'm going to recommend all of you use is something called VirtualBox. Okay, VirtualBox is an Oracle product. We've all heard of Oracle. What does Oracle make? Yeah, it makes databases. You know, a lot of folks don't know that. She does because we probably run off of Oracle in some of our things here, do we?
No, I was at Oracle Database Administrator.
Okay. Yeah. Yeah, but so a lot of folks, they've heard the company. You know, they've seen it on NBA games and stuff like that. In fact, you know, we have Oracle Arena, right? And we don't know what they do. No clue. They're also the Java people, by the way. Well, now, because they bought Sun Microsystems. But in any case, one of these this is going to be an application you install on your computer. So for most of you, you're going to go out here. I have a link on Blackboard for it to VirtualBox. Don't I? Oh, interesting. I have the video. I have this, but I don't actually have a link to it. So VirtualBox is Oracle's free virtual machine. It is not as good as VMware or Parallels, but it's good enough, and it's free. And you're just running a simple, small Linux distribution. Okay? So the idea here is you have your host operating system, whatever your machine's natively running, you install a hypervisor, then you create virtual computers. So I can create a virtual machine that's running Windows 10. I can create another virtual machine that's running Ubuntu Linux. Another one that's running Raspbian Linux. All right, so that's my current setup I have on this computer right now. Is on my machine, I have this hypervisor called Parallels, and I have 3 operating systems, 3 virtual machines that I have on here. So I have Windows 10, I have Ubuntu, and I have Raspbian. Right now, all 3 of them are asleep. They're not using any of my system resources. But each of these guys, I have through their settings an amount of system resources associated with each one. So if I click on the settings here for Windows 10, I see that I've given Windows 10 16 gigs of RAM. And you can set like a certain hard drive amount of space and stuff like that. So 16 gigs of RAM and where's my number of CPUs? Is that on the screen?
Processors?
Yeah.
It's 8.
Oh, it's grayed out for me, sorry. Yeah, processors. So I give it 8 processors, so 8 CPUs, and 16 gigs of RAM. It's a pretty solid Windows machine, right? Okay, so when I run Windows, I'm giving up 8 processing cores and 16 of my 64 gigs of RAM. So as long as Windows is running, those resources are set aside for Windows. My Mac OS, my host OS does not get those. For Ubuntu, it has significantly less, I believe. So this guy has 2 processors and 1 gig of RAM. I can give it more if I want, but Linux uses relatively small amount of system resources.
What do you use this operating system for? Exactly,
I use it in my operating systems or systems programming class. We're writing an operating system in there, and if I'm running Linux, it's probably my preferred version of Linux. Now, historically, I used a distribution called Gentoo Linux. I also used Red Hat a long time ago, but Ubuntu is, if there was the Apple version of Linux, Ubuntu is the version of Linux where things just tend to work. If there was a thing like that. Raspbian. What do I have on this guy? Two processors. I give him 2 gigs of RAM. I only have Ubuntu as. Why do I have so few on Ubuntu then? Huh. I might have to update that. I didn't realize I'd given so little to Ubuntu. But regardless, these are the machines I've virtualized. None of them are using my system resources right now, but if I want to run Raspbian, for example, I'll hit play there. Now Raspbian is running. There's that OS.
question. So if you're not running any of them, all the 64 will automatically work for the Mac?
Yep,
Okay. So it's not like just empty.
correct.
Or all of it. Okay.
Yeah, so there is, now I have Raspbian and Ubuntu running. So there's Ubuntu, there's Raspbian. Notice Raspbian's on a smaller screen because it's designed for the Raspberry Pi. It's a lower system requirements. This is why I recommend it in here. Also, Raspbian already has the Python tools and stuff like that in here that we're going to be using. And we'll look at that in a bit. And then when I'm done with something, I just shut it down. Done with Ubuntu. Just put it to sleep. Kind of like closing the lid on the laptop. Same thing with Raspbian. So now I have all my resources back. But you can run multiple operating systems at the same time.
Any heat problem?
I haven't had one, but I'm mostly doing software development on them. Not, I mean, with technically with Parallels, you can game because it'll allow you to use your direct hardware. So you can go full screen mode and play games, Windows games on here. I would presume, I don't know if I'd have a heat problem, but I would have heat at that at that point. Okay, so that's the scoop. What I'd recommend in here is one way or another, get a version of Linux up and running. I've given you a video here on Blackboard to get Raspbian working with VirtualBox. Follow that video, download Raspbian, which is a Debian distribution of Linux, and install it with VirtualBox, which is also free. So all these are free, and give it, a gig of RAM on your computer or 2 gigs of RAM on your computer, depending on what kind of resources you have to work with. You don't have to give it tons. Very small amount of stuff. If that is just not doable for you, you can dual boot your machine with whatever flavor of Linux you want to use. So instead of running your host operating system, Windows or Mac, you can it'll install a bootloader called Grub, which will let you say boot into Linux or boot into Windows. You can have both of them on there, or you can do like a Raspberry Pi. They're like, you could probably get a cheap Raspberry Pi for $15, $10. Get like a Pi Zero or something like that, running Raspbian. It runs Raspbian. Well, this says wireless and stuff. So $28. Looks like you can get a computer that's running Raspbian. You can get a Pi Zero, just this part, for like $5 or $7. But yeah, whatever. I would run in a virtual machine if it were me, but if you want to go some other route, you can. But anyway you cut it, I want you to be working with Linux as your operating system. So that's going to give you experience that you're going to be using in industry. Okay. All right. Questions about any of that? All right. So let's start talking about programming. Several of you have said that you have written software. Most of you kind of indicated that you're beginner, intermediate, or less, or something like that, right? Now, but all of you at some point have had programming classes, right? Okay. Programming, most people, I mentioned earlier that a lot of IT folks, they switch to IT from computer science to avoid programming, right? Why? Why is programming perceived to be hard? What's hard about programming? What's the purpose? What's the purpose of computer programming? Okay, you certainly solve problems. Specifically, what are we doing? We're telling this guy what to do, right? We're bossing computers around. This guy is a collection of resources that can do a lot of repetitive tasks without error better than I can. But I need to be able to tell this guy what to do. Make sense? And a programming language is the tool that lets me do that. Make sense? All right. So, are computers smart? They can't do anything on their own, can they? Are we smart? Well, except you. But I mean, the rest of the group is what I was referring to. I promise I had him for 4 years. It was a rough 4 years. Humans are smart, right? We're amazing problem solvers. We're so good at solving problems, we have trouble articulating how we do it. First day of class, I ask beginning programming students, how many of you got to class today without bumping into any walls? Right? And you get the couple of smart asses like, oh, yeah. But, you walk in the hall during, at night, it's a lot easier, right? Because you don't have the crowds. But, you're in the halls at 11 a.m. in the morning in here, out here, people going all over the place, right? What do you see? You see that person with their phone. They're texting, they're bobbing and weaving in and out of people, not even paying attention where they're going. They didn't fall down, they didn't bump into any walls, they're zigging, they're zagging. How hard is walking? How do you walk? Can you tell me every little tiny muscle trigger you have to fire in order to walk? We don't know, we just do it, right? We figured it out when we were babies. We stood up, we fell down. We stood up, we fell down. We stood up, we almost fell down. Then we wobbled, and then we fell down. Over time, we figured out how to not fall down and move, right? We don't even know how to articulate how we walk. Walking is a really, 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 really complex task, isn't it? So much so that we couldn't really articulate how we did it. Even if we could slow ourselves down and break it down into individual pieces, there's no way we can tell a computer exactly how to walk. It's just kind of beyond us, right? It's too complex of a task. That's why we don't have robots that are conveniently walking, around right now. Because we can't write software where a human being is articulating how to do it. This is where we have the rise of machine learning and artificial intelligence, right? We're trying to model a simplified version of the human brain and then trying to teach it that idea of stand up, fall down, stand up, fall down, stand up, almost fall down. Just keep making little adjustments each time until all of a sudden it's walking. We have no idea how, and then you see the movies, Terminator, Matrix, it ends poorly for us. It's what happens. But, punchline is that we can only solve problems, we can only tell a computer what to do if we know all of the little tiny baby steps that have to be taken in order to solve the problem. And human beings are so good at solving problems that we are, at the very least, not very good at slowing down and articulating all those little baby steps. Make sense? All right, so something I think about here is that computer programming is a skill set. The language does not matter, whether you've had C#, Python, Java, C++, C, doesn't matter. Programming is a skill. We then apply that skill to these different languages to tell a computer what to do, right? So in here, we've agreed upon a language, right? We've agreed upon English as our communication language because that's the language I speak. Several of you in here speak more than one language, right? I don't. Well, if you count programming languages, I'm okay, but natural languages, I speak English and bad English, and enough Spanish to order at Taco Bell. But, the idea is that, so, for instance, several of you, how many of you do know another language? Just by looks, I'm assuming most of you, right? We know a separate language, and in the United States, we usually have to take a separate language in high school or something like that we then forget, right? My wife won some sort of Spanish award, like best Spanish student in the state of Illinois or something, and she can't order at Taco Bell now, so that's out the window. But in any case, so for those of you who do speak multiple languages, and especially I assume some of you speak in your other language now, right? You have your friends around here and stuff like that. Does your mindset change when you're talking to a human being? Okay, whether you're speaking English or Arabic, you're still talking to a human. So your thoughts are identical, right? It's still a person. The words that are coming out are different, right? But the way you're forming your thoughts, the way you're communicating with the other person is the same, right? We're very, very, very skilled at talking to people. Not so skilled at talking to computers. People can fill in the blanks. They can fill in the gaps, right? Not so much computers, all right? So we're trying to get programming as our skill set, not paying attention to the language so that whenever we need to solve a problem, we use the right tool for the job regardless of what that is. Now I like to start off with this idea of how do human beings solve problems. We use our memory, we ask a lot of questions, and we use repetition, all right? 100% of programming languages have facilities for these three things. Every single one of them. Typically, memory is given to us through something like variables. Asking questions is through conditionals, if statements. Repetition, loops, and functions. Every single programming language will have facilities for these three things. If it doesn't, it's not a programming language. That doesn't mean it's bad. So for instance, if we just quickly throw it out there, HTML is often thrown around as a programming language. It's not. HTML is a data representation language. There's nothing wrong with it. Can't define variables, can't ask questions, can't write loops or functions in HTML. In fact, if we scroll down here, how does the internet work? So we use our client-server model, right? Which is a networking abstraction for web client and web server. And what's a web client and a web server? Well, a web client is probably our web browser like Chrome. Web server is going to be like Apache or IIS. So Apache if you're running anything that's not Microsoft, IIS if you are running Microsoft, Internet Information Server. All right. What language does a web browser speak with a web server? It speaks the HTTP language, that protocol, right? The HTTP language is a very simple language. English, very complex. Arabic, very complex. Python, less complex, but still pretty complex. HTTP, very simple. 4 functions. Get, put, post, delete. HTTP knows how to do 4 things. We'll talk about that more in later class, but simple language. But that's all the communication that has to happen. When the browser says, I want this page, give me that page. The server then has the job of serving that page. Now, the only thing a web browser can accept as a return is HTML, CSS, and JavaScript. Our evidence here that HTML is not a programming language is the fact that JavaScript is part of what it accepts. JavaScript is a programming language. So anything on a web page that needs to be dynamic, that has to remember things, ask questions, do repetition, has to be done in JavaScript because HTML can't do it itself. That's why JavaScript is a common part of web pages. Make sense? So no matter what happens over here on this server, your web browser is expecting you to send an HTML, CSS, and JavaScript. All right? So if the browser makes a GET request in HTTP and says, give me index.html, the web server is going to look at the end of that and say, the MIME type here is HTML. No problem. It's already in the format that I'm supposed to give them. I'm not going to do any extra work. I'll go and find the file over here, and I'll toss it back to the browser. Good to go. But then he asks for index.php. MIME type is not HTML. PHP is a programming language, which implies that a file that has a .php extension is likely a computer program that needs to be run. And we hope the output of that program is HTML, CSS, and JavaScript, because this web server is going to run this program and spit out the output, and this dude's expecting it to be HTML, CSS, or JavaScript, because that's what browsers eat, right? They turn HTML, CSS, and JavaScript into pretty pictures and text. Make sense? All right. So this server's job is to receive HTTP requests, fulfill those requests, and ultimately spit out HTML, CSS, and JavaScript. Whether that means we're directly spitting it out, or we're running this PHP program first, or we're running this Python program first, or we're running a Ruby program first, whatever it is. Make sense? At the end of the day, this guy expects that format. So our evidence that HTML is not a programming language is the fact that JavaScript has to be his close buddy in order to accomplish the things that we think are required on web pages. Right? If we go and put in our username and password and we forget to type in our password, usually it'll say, please enter your password, right? It hasn't sent that to the server yet. JavaScript did the testing and said, if you didn't fill in this box, I will scream, right? If you did fill it in, then I'll try to send some crap and we'll see what happens. We'll roll the dice. All right. So, this guy over here, we call this all client-side programming or front-end development. Back here would be server-side programming, back-end development. This kind of puts things in context. We want to see how our modern languages fit in the context of programming languages because, again, the language doesn't matter. So whenever we're trying to solve a problem, you mentioned earlier, what's the job of a programming language? To solve problems, right? Specifically tell a computer what to do. But when we solve a problem, we want to pick the tool that's best suited to that problem. Or at the very least, the tool that we have available to us that's best suited to the problem. Sometimes tools aren't available because they're too expensive, or we just don't have one, whatever it is, right? But the more tools we have in our wheelhouse, the more things we can apply to real-life problem solving. All right, so I like to look at programming languages from kind of a lineage perspective. And I try to start with like the C programming language. So C came out around 1968-ish. It was a language designed specifically for creating operating systems. We spent quite a bit of time today talking about operating systems, so we're going to be closing some loops here in the next little bit. Okay, so I'm going to walk down this chain over here in a little bit, but I'm just going to finish up this one first. So I call these our web programming languages. I call these our native programming languages. Now, realistically, I've put Python over here in our web programming languages, But more modernly, Python has been heavily used in areas like data science, machine learning, stuff like that. So if you do a search for what's the most popular programming languages, your top 3, they might flip around a little bit, but you're probably looking at Python, Java, C++. You know, you're going to have C# in that top 5 and maybe C somewhere in there, whatever. But Python's in that top 2 or 3 typically. So we look at it also, it's a good first language to work with, and I'll kind of tell you why I think it's a good first language. Several of you have mentioned you've worked with Python before, so we'll see when we get to that point if you can guess why I think it's a good first programming language, especially when you consider this slide right here where I've said the language doesn't matter. So maybe brainstorm that for a bit. All right. So in any case, you know, what we see here is the evolution of our web programming languages here, where in the very, very early days of the web, if you were a Unix system administrator, you were using a scripting language. Well, if you weren't using one of the shell scripting languages like SH, CSH, Bash, you know, if you're a Linux user, Bash is your, you know, that's what the terminal runs. So if I come back over here, well, here you might be able to see it. Well, whatever. I'll just come in here real quick.
You can see Bash from the Mac terminal as well.
Yeah. But so if I just type in Bash, this thing's running the Bash shell. If I type in CSH, I assume I have CSH. No? SH? Yep. So there's the original Unix shell is SH. All right. And as he pointed out, I don't have a terminal open here. On a Mac, it's running on top of Unix, so you also have a Bash shell. Oh, the default shell is actually ZSH now instead of Bash. So I had to switch over to the Bash shell if I wanted it. But in any case, those shells each have their own scripting language associated with them, which I promise you is based off of C. They're a C-based language, scripting language. But if you were a Unix system administrator and you were creating websites and things like that for people, you would have been processing web forms using Perl, SH, CSH, whatever. So before we had, we're probably dating ourselves a little bit here, but before we had modern internet, modern web servers, and we had a web form, put in username and password, hit the submit button, that has to go somewhere. We take for granted today that this picture works, that these web servers here just work, that they can get requests that are HTTP based requests and respond to them, even if that request comes in, like for instance, a post function where a lot of your information like username and password might be embedded inside of it. Before this, the way this was accomplished in the very early days of the internet, when we were having Unix system administrators somehow trying to hodgepodge their solution together to serve interactive web pages, we had a technology called CGI, Common Gateway Interface, that allowed you to process web forms using any programming language that you support on your Unix machine. You know, today we think about processing web forms using Python, PHP, Ruby on Rails, you know, one of our modern web languages that has built into it some fancy way of conveniently dealing with HTTP web requests. But back then it was like, look, this dude is sending me a web request. I need to process it somehow. So you used a common gateway interface that allowed you to connect an HTTP request to your program. Write your program in whatever way you want. You can write it in C. You can write it in COBOL. How many of you have ever programmed in COBOL? My wife is a COBOL programmer. To this day, she's a COBOL programmer. and works for a university I used to teach at, Western Illinois University. She works remotely for them on a mainframe. And they process their web forms, their website, using COBOL with a IBM product called WebSphere that translates modern HTTP calls into COBOL understandable things. So rather than update their software to be modern, they're just going to keep using the old stuff and put tools in between to translate to the old stuff. They're finally actually starting to make the switch, but it's, it is what it is. Okay. Now, let me ask this question. Oh, here, let's look at these. How many of you have heard of Ajax, jQuery, Angular, React? Okay, we got one person who's heard of it. Anybody else heard of it? Yeah, I'm cool with heard of it. Okay, because one of the things we run into in technology is typically, and we all have our expertise, right? So I've been exposed to a lot of things, but there's, especially you get this more in grad programs. Several of you are working professionals. You've been exposed to technologies I haven't. So there's going to be things you've worked with that I've never worked with, right? Okay, but one of the things we run into as technology professionals is we really like coming up with buzzwords that mean easy things. And what we really love is coming up with buzzwords each year that mean the same thing, right? Like right now, machine learning means the same thing as data science, which means the same thing as data mining, which means the same thing as, keep rolling back to day one of computing, right? We just keep renaming stuff, repackaging stuff to make it sound sexy. All right, so Ajax, jQuery, Angular, React, all of us have heard of some subset of those in passing. Anybody know what those are for? What problem does Ajax solve?
I think it makes web pages more dynamic.
Okay, I think we're onto the right thing there.
I heard, yeah. So I heard of Ajax.
Okay. Anybody want to give me an example of where Ajax might be used?
I can give an example, but it won't be that accurate. It makes search bars give like answers.
Okay, so as you're typing,
Yep.
it starts filling in like a guess of what it thinks you mean, right? Okay, I think that's probably accurate. It might not be Ajax, might be one of the newer ones, but it's all the same, rebranding and the same thing. Simple example. Let's say you're watching, some sports game, whether it's Super Bowl, cricket, whatever. Pick your favorite sport, right? And so we're going to think about the Packers game. So we're watching a Packers football game, American football, of course. So we're watching a Packers football game, and we have a website up that's showing us the current score. Do we have to keep hitting refresh to see the updated score? We used to. What does Ajax let us do? It lets us identify a little part of the screen and have that one part refresh in and of itself. That's what Ajax does. What does jQuery do? The same exact thing, but jQuery gives us the ability to walk the document object, the DOM object, on your page through JavaScript to more conveniently get to the places on the screen that you want to be able to update. Where Ajax was kind of a hack. Ajax was like, okay, here's the technology to upgrade a part. Now you got to figure out how to get to that one label, one tag that you want to update. Where jQuery gave us a standardized way of walking the DOM object. That's what it's called. Okay, what about Angular? Angular and jQuery are the same. They're competitors. Angular is Google's. jQuery, anybody know? I'm sorry. Anybody who made React? Facebook. So same tool, same solves the same problem. Mortal enemies. Not really, but we'll just call it that, right? Everybody hates everybody, whatever. Okay. What problem does Angular solve? already we're probably seeing a trend here, right? That we're seeing an evolution of the problem. Ajax kind of solved the original problem. jQuery solved the same problem, but maybe a little bit better. Angular, we could probably start with that. It solves the same problem, but a little bit better. Well, better how? Angular lets us do two-way communication. So instead of just pushing things to the website can push things to the database or to the back end in real time. Two-way communication. Angular way, React way. All right. Now, all of these guys are just JavaScript libraries. This isn't some newfangled technology. It's some smart person used JavaScript, this language that's been passed to web browsers forever and ever and ever since the internet started, and said, you know what? There's some things that we think we need to do on these pages, so we're going to write really complex JavaScript libraries that solve these problems. And then we're going to give them interesting sounding names, and we're going to make people use them. A la Ajax, jQuery, Angular, React. Just go out there and look up, a lot of times they don't call them libraries. The cool kids call it JavaScript frameworks, right? Heard that? Heard the framework buzzword? It's a collection of functions. Frameworks, APIs, whatever. All right? So all this stuff, all these new buzzwords that come out every single day are based off of things that have been around since day one of the internet. You know, at some point, as we get into things called, how many of you have heard of APIs? Here, we're just going to do it now because that's where my mind's going right now. What's an API? Application Programming Interface. This is what it stands for. What is it?
It's like a tool to communicate between, use APIs to communicate between database and servers.
Okay. So is this a collection of functions that can be called on a remote service? Could be a data source, I'll just say etc. Right? So for instance, if I want to get the directions to Bayshore Mall from here, do you think that Google Maps probably has an API where I can send information to them saying, I want the directions to get to this address, and will it send me back a result that gives me my turn-by-turn directions? Does that seem like a service that Google Maps might provide? It's probably one of their API calls, right? Okay, so that's what an API is. That's the problem it's solving. How many of you have heard of REST or RESTful APIs? Seen those things? All of our modern APIs are REST or RESTful APIs. Every one of them. Very, very, very high tech. Just invented yesterday, probably. What are RESTful APIs? You just, well, I mean, I just told you, Google Maps, RESTful API. Facebook, RESTful API. Pick your favorite, Yelp, RESTful API. They're all RESTful APIs, promise. Every one of them.
They're the same thing.
So RESTful API is our modern name, our modern standard that APIs follow. Before that, we had something called SOAP, which was kind of sort of a standard. Before that, we had proprietary, hey, you want to talk to our service, let's agree upon a made-up language that we'll speak, and nobody else, if you want to, this is how we talk to Google Maps, you can't talk to Yelp that way. Because, we're not talking to them, we're proprietary. RESTful APIs are a standard, right? Now, what's funny is we might imagine in our head that RESTful APIs, the standard is this newfangled, amazing type of thing, right? Remember earlier we were talking about HTTP? We've seen it in web browsers, http://www.google.com, whatever. So this is the language of the of web, of the internet, right? And I mentioned it's a really simple language, right? 4 functions. Get, put, post, delete. HTTP, Hypertext Transport Protocol, has been around since the beginning of the internet. And it's always had 4 functions. Yet, we've only ever really used 1.5 of them. We use get for every single web call. If our web browser asks for www.google.com, that's a get request. Sometimes we make post requests when we have a web form that we submit. But even a lot of web forms are submitted using get requests, where you see the information up in the URL. It builds out a big, long, crazy URL with like question marks in it and stuff like that, where it'll say username equals this and password equals this. That's a really crappy old website if they're passing the password in plain text up in the URL. Okay, but instead we could do a post request where it's still in plain text. You just don't obviously see it. Anybody who's running like a packet sniffer or something like that would get it. That's why we have SSL to encrypt the data behind the scenes, right? All right. So at most, we've been using gets and posts for web stuff for a long time, but we had 4 functions. Now, for years and years and years and years, we've had proprietary APIs. Then we had this kind of loose standard for APIs called SOAP, where maybe you had 3 or 4 different versions of the SOAP standard. And then finally they said, you know what? When we're dealing with a data source or a service provider like Google Maps or something like that, we can accomplish everything in terms of 4 types of function calls with corresponding endpoints. So a get function call says, I want you, the data source, to give me some information. And then there's various endpoints for that information. Turn-by-turn directions, current traffic, current weather, whatever it is, various endpoints, but I'm making all those requests with a get request, which says, here, give me information. A put request would also have an endpoint, but this allows me to add new information to the data source. A post request is also calling an endpoint, but it's because I'm using the function that is post from HTTP, it knows that I'm changing existing information. It's expecting me to give it some data. Usually that data is in JSON format. We'll talk about that here in a second, closing some more loops. Delete, that function, we're going to call an endpoint. That's going to delete a record, something like that. So we've taken this super old school HTTP protocol that's been around since day one of the internet, certainly time tested, right? So you know what, why don't we just imagine every single one of our APIs in terms of the HTTP protocol? And then we'll call it REST APIs. That's what REST or RESTful APIs are. They're APIs built on top of the HTTP standard. Earlier, what are we doing on time? Okay, we're okay. Data representation languages. How many of you have heard of XML? What is XML? Start to see a pattern.
It's data storage. It's a way to store data with tags.
Okay. Tag-based data representation thingy. Okay. What about HTML?
For me, there was
Which came first, HTML or XML?
HTML.
HTML came first, and it inspired XML. So HTML is a tag-based language for representing information associated with a web page. Somebody looked at that and said, you know what? We could use tag-based stuff to represent other things. Like maybe we have a person, and a person has a first name and a last name. That would be an XML representation of a person record, something like that. All right? Now, that's what XML is. Now, you could actually create HTML using XML. So, XML officially is a language creation tool. So, you create the standard for your language, and then, because you have parsers that will make sure your language is accurate. That's actually the problem with HTML. If you look at modern web browsers, somewhere hidden in there, there's usually a setting to put it into XHTML mode. And if you click that, half the websites stop working. Because XHTML says my web browser is now in a mode where it will validate accurate HTML code. That means every opening tag has a corresponding closing tag, so on and so forth. Now, HTML, so if any of you have ever done any web development stuff, you know you've had to test your pages on different browsers. Because different browsers have different takes on what's considered reasonable HTML and how do I interpret this reasonable HTML. And realistically, not that we're necessarily going to point fingers because everybody's probably guilty at some point, but is probably started with a tool from Microsoft called Front Page. So years ago, in the early days of making web pages, Microsoft had a product called Front Page, which allowed you to effectively create a Word document and save it as a web page. And it would generate incorrect, incomplete HTML code that happened to work fine in Internet Explorer. So kind of one of the main, like a common thing was like for list items. If you have an unordered list, you'd have an opening UL tag and a closing UL tag, and then you'd have a bunch of LI tags in there for list items. Well, each of those LI tags should have a closing LI tag at the end of it. Front Page did not do that. Internet Explorer made it work fine. Just ignored the fact that it didn't have a closing LI tag. Now, at that time, Internet Explorer is a really popular browser. Anybody who got a computer that was connected to the internet knew that the internet lived behind the blue E. Right? You double click the blue E, that's what Internet Explorer's logo looked like. Blue E. Right? Now they call it Edge. And they hide it someplace else because it's got bad connotations now, right? Okay, but the internet lived behind the blue E. So since it worked in Internet Explorer, if you're Netscape, now called Firefox, or Chrome, which didn't exist back then, if you're any of these other competing web browsers, if you're going to even compete, don't those pages need to work in your browser too? So you ruin your standard as well. So all the different browsers started saying, we're going to accept all this garbage. There's 11,000 different versions of HTML that we'll pretty much accept. If it's close, we'll show something. So that's why you have to test your code in all these different browsers because they've made provisions for poorly written HTML. And that's why if you want to see which sites are properly written in HTML versus which sites have probably either used a junky tool or was handwritten by a lazy web programmer or is a hodgepodge of something left over from a long time ago, switch your browser over to XHTML mode and see what breaks. I think you'll find quite a bit breaks. But anyways, XHTML is a implementation of HTML using XML, even though XML was inspired, its existence was inspired by the existence of HTML, that tag-based approach. Now, what would we say is the problem with this tag-based approach? If you were looking at this, what weakness might you point out? What's the obvious weakness? Or what might be an obvious weakness of this guy? XML, what I have on the screen. Just look at this example right here. If you were nitpicking, what might you say is the problem with that? Is it easy to read? Like, can you pick out that this is a person whose first name is Mike and whose last name is Lippman? Yeah, that's easy enough, right? How much data am I representing there? Mike and Lippman, two little pieces of data. How much crap have I written there to represent two pieces of data? A lot, right? So there's a lot of fluff with XML. It's not that it's not that it's not easy to read, and we might even say, who cares? We have plenty of storage, right? But it is not that efficient. So if we look at how many of you have seen JSON or heard of JSON? Do you know what JSON is?
All I know is just based in JavaScript.
Okay, tell me more. I said that's all I know.
JavaScript object of something. But I don't think it's
Yep.
actually.
JavaScript object notation. That's what that guy stands for. You know what? If you were a JavaScript programmer and you wrote object-oriented code in JavaScript, guess how you write your objects? Using JavaScript object notation. That is the syntax in JavaScript for writing objects. Well, I guess technically, if I want to make these guys equal, I would call this like first name and last name, something like that. That's the JSON version of that same piece of information. First of all, it looks very programmy, right? See the curly brace things? Where have we seen those curly braces? We starting to see the connection here? Okay. All of these things are all related to each other, even though they seem unrelated. So, JSON has been around for years and years and years and years, hidden inside of the programming language called JavaScript. It's how you wrote objects in JavaScript. And then all of a sudden we started having a need for sending information between one application and another application, right? Maybe you got your turn-by-turn instructions from Google Maps that send it to you in JSON format. Maybe you had to send some information to update a student record or something like that. You sent that updated record in JSON format. Okay? We've agreed upon this new standard way of organizing the data so that we can have tools specifically designed for working with it. Before that, what did we have? Like comma-separated values, CSV files? You know, your accountants are still using those, right? Excel, you can export something as a CSV file. Now you've put some limitations on yourself where you can't use commas in your data and amongst other things, but you also have limitations on collections of things and data types and this kind of stuff. JSON was sitting right there and said, you know what? With JSON, I can have collections of people. So here is a data, so a JSON object always starts with an opening curly brace. So we're going to say we have a value called people, all right? And people is going to be a collection. And here's my first people. Here's my second people. I'll make him my brother. I do have a brother named Dave, so it's not made up. All right. Then I'll close my collection. How many of you have programmed in C, C++, Java? What are square brackets usually used for? Arrays. Man, this looks a lot like programmer stuff, right? Okay, so I have a array of people. Here's the first JSON object. This is a person whose first name is Mike, whose last name is Littman. Here's a second guy in there. I'm missing a comma. This is first name Dave, last name Littman. Here's the closing of that array. Here's the closing of my JSON object. So this is a JSON object that has exactly one variable. Back to how do human beings solve problems? We use our memory. 100% of programming languages give us a facility for variables, emulating memory, right? So here I have a variable named people. Its value is a collection type. This collection has a object type in it whose first name is Mike, whose last name is Littman, and then here's a second object in here, in the second element of the collection. First name Dave, last name Littman. This is the end of that collection. This is the end of this JSON object. And if I really wanted to, I can put in here like num people 2 or something like that if I wanted to store a second variable. JSON supports collections, XML does not. We had to give ourselves a distinguishing difference. In XML, we would have had to have another layer where we had, a people opening tag, a people closing tag, and then inside there we would have a person and another person. But we basically have to process through that and run into every person we'd run into rather than knowing that people here is a collection of things. So JSON gives us the ability to store collections. All right, but this looks very programmy, right? And who's usually using the information that's being passed back and forth between software applications and APIs? Programmers, right? Human beings, even though we could look at something like this and read the XML, even though we could go to a web page and right-click on here and say View Page Source, and in some world, after that finishes loading, be able to read through that CSS and HTML. This isn't for human consumption, right? Programmers are working with this. Probably program code is going to be manipulating this. Make some sense? All right, so the fact that programmers are already used to a certain kind of syntax like this, and that JSON also supports collections, and that we don't have to invent a new proprietary standard, people are already familiar with this, we might as well stick with it and use this for sending standardized information between applications. Okay? Whether you're writing scripts in the IT world where you're sending stuff from server A to server B, 9 times out of 10, especially if you're using modern tools, you're sending it in JSON. Okay, if you're using a little bit older tool, you're sending it in XML. If you're sending it proprietary, you need to upgrade your tools, right? Unless you just paid too much money for it and the system already works and we're just not going to change, which is usually the case, right? Okay. Let me just see where we are. All right, so let me just finish the loop here, then we'll start with programming in the next hour. How many of you have heard of Node.js? Okay, tell me anything about it. Let's go back to this chart right here. Actually, I want to go to this chart right here. So we talked about client-side, front-end developer stuff here. We talked about server-side, back-end developer stuff here. Our server-side languages that I've talked about here are kind of like PHP, Ruby, Python. These are common ones you maybe have heard of. There's 1,000 other server-side languages, but PHP, Ruby on Rails, Python, these are pretty common server-side type languages. So if you're a server-side programmer, you're comfortable in those languages. If you're a front-end developer, a client-side programmer, you're working primarily with HTML, CSS, and JavaScript. Now, you might, depending on the type of work you do, you might say, well, a majority of what I do is about making things look good. Fine. So you're effectively a graphic artist who dabbles in code and HTML and stuff like that to get it put into technology. Nothing wrong with that, but your primary role is making sites look good. But more times than not, especially in marketing agencies, boutique marketing agencies, they need folks that are a little bit more hybrid than that, right? They need to be able to make it look good, but also be able to make it work good. And a lot of times, these same folks might be able to do some of the stuff here on the back end that aren't crazy coding. A lot of the stuff on the back end might be processing a web form. Is this username and password correct? We're not talking about, you're not inventing a video game or something like that. You're reading in 2 pieces of information that was sent using HTTP over the internet. This script over here is going to grab those 2 pieces of information, check it against the database, and give a yes or no, right? That's what it's doing. So it's plausible that these folks have the ability to do a lot of the stuff on the back end. Because we might say, I'm just pulling numbers out of the sky, but maybe 90% of back end development is effectively grunt work, right? Maybe 10% is something weird, something interesting, joining a whole bunch of database tables or doing something crazy. At that point, you might push it over to the DBA. You might write a stored procedure or something like that to do your crazy stuff where you just call the procedure. But 10% of the time, if we're just making up a number, something very complex is maybe going to have to happen. But a majority of the time, it's not going to take some professional crazy programmer to write the stuff back here. But what's our weakness? Our weak spot here is, even though I started this conversation by saying the language doesn't matter, these folks over here are not necessarily trained as programmers. They're trained in a much more generalistic skill set or a hybrid skill set. They're artists. They are people who come from different walks of life and maybe have kind of transitioned into technology, and they've learned a skill in terms of the technologies they're used to using and haven't learned programming from the ground up, right? So what are they primarily working with in the front end? HTML, CSS, and what programming language? JavaScript. What is Node.js? Let you write the back end in JavaScript. Front end and back end, same programming language. Now, Node.js has a couple of cool features like streams and things like this, but at the end of the day, you could have a Node.js based web page where the stuff that's happening over here is not written in PHP or Python, it's written in JavaScript. Stuff that's happening over here is written in HTML, CSS, and JavaScript. If you're already familiar with JavaScript because you've been writing front end stuff for years and years and years, and now you want to go and dabble in the back end stuff and you don't have to learn a new language, aren't you already halfway there? As somebody who doesn't necessarily view programming as their superpower, but instead of a means to an end, that's what Node.js is. Let's merge the 2 worlds of front end and back end development by having one language, unifying the language between the 2 of them. Make some sense? Got some other cool features too, but every new language that comes out has another cool feature. There's nothing special about Node.js other than that. All right, questions about any of that stuff? All right, let's take 10, and then I think we're ready to dive into code.